Hello, everyone. So welcome to our third video of Unit 3, I guess the 12th video altogether. This one, like the last video, is also basically about two different topics. We're going to say a little bit about what it means for a function to be increasing and decreasing and constant, and those are words that we're going to start using. And then we're also going to talk about two theorems about continuous functions. Okay, so again, very good video to take notes on, especially with those theorems. All right. So getting started here, I actually pulled up this graph from Google today. I asked Google what the stock of Apple was today, and this is what it told me. So this is a graph of a very complicated function where the x-axis is representing time and the y-axis is representing price. So it's a very complicated function, but it does happen to be a continuous function, that over time the Apple stock is fluctuating up and down, but it is definitely continuous. There aren't any jumps or holes or anything like that. And I just want to point out a couple things that we can use to describe this kind of a function. We can say that at certain times during the day, the Apple stock was increasing. And what that means is that as the x increases, the y value, the price, is going up. So for example, like this, during this period here, it seems to have been increasing. During this period over here, it looks like the function is decreasing. Okay, that stock is decreasing. So very complicated function, but at times you can say that that stock is increasing, at times you can say it's decreasing. And we're going to apply those words to functions in general. Okay. So this is about the words increasing, decreasing, and constant. All right, so very important to follow along. So say that throughout this entire slide, this entire talk, we're imagining what is happening as x is increasing. So suppose that as x increases, y increases as well. Then we say that the function as a whole is increasing. Okay. So suppose that x, as we still increase x, this time y is going down. Y is decreasing. So then we say that the function as a whole is decreasing. If, as we increase x, y stays the same, it neither goes up nor it goes down, then we say that the function is constant. Okay. So I think these are very easy things to see on the graph. But the important question that each of them is asking is, what is happening to y as x increases? Okay. Now, most functions, they don't just increase, they don't just decrease, they don't just stay constant. They do all of those things sometimes, right? Or more often, they increase sometimes and they decrease sometimes. It's very rare that a function will suddenly start becoming constant, but it can happen. Okay. So for example, I've drawn a graph of a function here. Kind of a weird piecewise function, it looks like. But we can see that it starts out by increasing. That's because as x goes up, as I move to the right, I'm always imagining that I'm moving to the right. As I move to the right, y is going up. Then at this particular point, at this little peak of the mountain here, the function starts to decrease, which means as I increase x, y is going down. In this third interval here, it looks like as I increase x, y is perfectly constant, or at least that's the intention. It's supposed to be perfectly flat right there. So in that case, we say that the function is constant. And then in this last interval, the function starts decreasing again. Okay. So what I can ask is a question like, on which intervals is the function increasing? I would say from minus infinity up to whatever this x value is. And I could say, where is the function decreasing? And you would answer from, in this second interval, I'm staying away from particular x values right now to keep this very visual. But you could say that it's decreasing in this interval here, and then also in this last interval. Okay. And then if I asked, where is the function constant? You would answer in this third interval here. So those are very difficult things to solve for algebraically, and in fact, that's actually a question that you're going to answer in calculus class next year. But if we look at the graph, especially if we use Desmos, then we can at least get an estimate for on which intervals it's increasing, on which it's decreasing, and on which it's constant. Okay. So if we go back to this Apple stock, by the way, it's really messy, right? There's a lot of intervals going on, and from time to time, yeah, it's like increasing in this little interval and then decreasing really quickly and then increasing again and then decreasing and then increasing. So that question, where is it increasing and where is it decreasing, would be extraordinarily complicated for a function like this, or there'd be lots of tiny little intervals on which it's doing each one of those things. Okay. So then now we're going to move on to the two theorems. Okay. So what's happening with these are two theorems that are always true about continuous functions that have certain properties. Okay. So most theorems in mathematics take the form of an if something is true, then something else is true. Okay. So they have what we call a hypothesis, which is the if part, and then a conclusion, which is the then part, right? So for example, like a theorem a few videos ago said that, if you have a polynomial that has real coefficients, then it factors into linears and quadratics, right? Same kind of thing here, but each of these is going to start with a continuous function. So the first one is, if f is continuous between two x values, a and b, and if c is some y value that happens to be between f of a and f of b, then there is an x value between a and b such that f of x equals c. All right. Now, I think that is important to write down, but it's just as, if not more important, to see visually what this is saying, because this is saying something that I claim is not really that surprising once you break down what the heck is going on with all of these variables. And I think this example is key to being able to see this. So the a and the b give me the two endpoints for x. All right, so left endpoint, right endpoint. Okay, and the function is continuous between these values, which means that it doesn't have any jumps or holes or vertical asymptotes. Remember, that rule of thumb is that I can draw the graph without picking up my pencil. Okay, so that's true, and if I pick some c value, which is a y value between the starting y value and the ending y value, between f of a, which is the very first y value, and f of b, which is the very last y value. So I picked something in between there. And what this theorem says is that the graph has to cross this particular y value, meaning there has to be at least one point that hits that y value. And on this particular graph, we can see where that happens. That happens here. But the theorem doesn't actually really tell you how to find that point. It just says that the point has to exist. If I'm going to get from down here to up here, and I'm going to do so with a continuous function, then I have to cross this dotted line. And furthermore, I have to cross any dotted line that's between the starting value and the ending value. Okay, let's go back to the Apple stock to say this one more time, okay? So in this particular graph, here's the starting value, and here's the ending value. And if I pick some dotted line that's between those, some y value that's between those, some horizontal line between those, then the graph has to cross that horizontal line. And the Apple stock is so complicated that it crosses it a bunch of times, okay? If you actually try to count how many times it crosses, as I did, it ends up being something like 5 different times, right? But all the theorem says that it has to cross at least once, right? It's saying there is an x value. It doesn't say how many x values there are. It just says there's at least one. Okay. The second theorem that I want to talk about today is the extreme value theorem. All right. So intermediate value theorem is talking about y values that are between the starting point and the ending point. That's why we call it intermediate value. So the extreme value is talking about biggest points and smallest, or biggest y values and smallest y values. All right, so in this case, the if is, if the function is continuous on a closed interval, And this time it is important that it be closed, that it actually contains the two endpoints. And in class, we'll talk a little bit about why that is. Then the graph has to have a largest y value and a smallest y value in that interval from A to B. Okay. So A and B are basically playing the same role that they did in the last theorem. And there's no C this time. The conclusion is just that between the x equals A and x equals B, there's a point with a largest y value. Okay, so we like to call that a maximum to the function. And there's also a point with the smallest y value. And in this particular example that I've drawn here, here's the largest and here's the smallest. In this case, by the way, the smallest y value happens to be exactly at x equals b. And that's why it's so important that we include those endpoints in our interval, because these extreme values, these maxes and mins, might happen to be at the endpoints. Okay. All right. So this is this relatively simple function where we can see that max and that min pretty quickly. Let's go back to the apple stock. All right. Again, it's going all over the place, but if it starts here at the left and ends here, and that's a closed interval, then there has to be a maximum y value and a smallest y value. So the largest y value, see if you can spot where that is on the graph. Okay, and if you're having trouble spotting it, it's right here. So this is the largest y value on this particular graph. It's like the maximum price for that stock, right? If you had to sell your stock this day, this is the time of day in which you would want to sell that stock, right? So that you could get the maximum value for it. All right, so what about the minimum? All right, well, it looks a little bit, I have to say, there's kind of a debate here, whether this is the minimum or this is the minimum, or maybe they happen to both be the minimum. Maybe the smallest y value happens right here and right here. But remember, it's not really the x value, it's the y value. So the smallest y value can happen at two different points. And that's actually okay. If it's the same y value for both of those, and they're both the smallest, then that's fine. Again, it's not about how many maxes and mins there are, there just has to be a max and a min. So I would say that if you had to if you had to buy your stock this particular day, you would want to buy it either at this time or at this time. Okay, because those are going to give you the smallest price. All right, so I'm going to go over this one more time. Intermediate value theorem says that for every y value between the starting y value and the ending y value, there has to be a point with that particular value. Extreme value theorem says that if we're continuous on a closed interval between 2 points, then there has to be at least one point with the largest y value. There has to be at least one point with the smallest. Okay. All right, so we're gonna spend some time. I'm sure you guys are gonna have questions about these theorems and the particular conditions behind these theorems, and that's great. I'm looking forward to addressing those questions in class. And the practice problems today will be about increasing, decreasing, and constant. All right, so I hope you have a great weekend. I will see you in class.